And we'll go from there. So our goal today is I can use a one sample t-test from you to draw inferences. So that's drawing conclusions. Just a friendly reminder, we are taping, so you will be on the video if you chat. So please, please be nice and quiet while we tape. If you have a question, they'll raise your hand and I'll answer. Yes? There are no cutouts today, so I will get the cutout for you, so leave some space if you want it. If anyone wants to write down, I'll give you a few seconds now. I'll pause it if you want to write it down. We're reading through the problem, and we've already read through it, and we know right now that there is a claim. And the claim is nationally the average runs in a game is 5.7. So I'm going to highlight that. Now this coach chooses 5 games at random, and he records the runs. So this is important as well, 5, 9, 4, 11, and 8. Is it likely that his team scores could have come from the national distribution? Assume an alpha level of 0.05. Well, the first thing we need to do if we're given data is we need to compute the statistics that come with that. Okay, so we need to find X bar and our SX. I have it on my calculator right now. One thing today after I'm done, I want to make sure that you remember how to use your calculator. It will be on the final. You have to get that stuff figured out before you take the final. I don't want to be helping you, like, if you get an error, I'll help you, but I don't want to just teach you how to use your calculator there. You should be using it all year long. If you want to do it with me right now and you have a graphing calculator, you're going to hit Stats. You're going to hit Enter on Edits. You're going to scroll your cursor up to L1 and hit Clear. And then you're going to enter the data. So I have 5, 9, 4, 11, and 8. Does anyone have any questions? If you have the smaller calculator, if you want to bring it up, I can show you how to do that. Yep. Okay, so I can talk. I'll talk you guys through it actually, since so many people have it. So if you have the little blue or pink or green calculator, what you want to do is you want to hit Second Data and hit Enter on 1 bar stats. So second data, enter on 1 bar stats. Do you see it? Raise your hand if you don't see it. Did you see? Okay, once you see that 1 bar stats, hit data again. And then you should see X1. Do you see X1? So then you're going to hit 5, scroll down, and then do you see a FRQ? Okay, so scroll down again. Do you see X2 now? Now you're going to put 9, scroll down. You should see frequency. Skip that, scroll down. Do you see X3 now? Okay, so now you're going to put 4, and keep going until you get to 8.
Does order matter?
Order does not matter, no. Once you guys get it, you're going to hit Stat Bar, and it will give you your X bar and your SX. And then the rest of you with the graphing calculators, you're going to hit Stats. You're going to arrow over to Calc, and you're going to hit Enter on 1 bar stats, and then Calculate. I'm going to pause it right now just to help people with their calculator. Make sure you have it. All right, so we just found our mean with our calculator. We worked on practicing entering things in our calculator. And for our mean, our X bar, we should have done, was it 7.4? Yeah. Okay. And our SX was equal to 1, was it 1 or 2?
2.88.
2.88? Is it 2.88 or 2.89 when you round? 2.88? Okay, perfect. Now, right now, guys, do we have evidence that this team is different than the national average? Yes or no? What is the national average? Let me scroll up. 5.7. So this team has an average of 7.4 based off of those 5 games. So right now we have evidence that they could be different than the national average. The question is it a significant difference? Meaning, when I flip a coin 100 times, if I flip 90 tails out of 100, that's significant. If I flip 52 tails out of 100, that's not significant. Yes?
How high can that bar go? Like, say the number is the low bar, how high can that bar go in terms of on there?
Oh, I don't know
Sorry
if there's
if I
a
said
limit. I don't know if I understand your question. I don't know if there's a limit to like how far from the average it can go. Yeah, I don't think there's a limit.
Oh.
Yeah. All right, so now in order to prove significance, we need to do a significance test. And our first part is the state step. And that's where we do our null hypothesis, our alternative hypothesis, and we state our parameter mu. When we did a one proportion z test, okay, or a one sample z test for p, we didn't have mu, we had dealt with p, okay? Mu is a Greek letter. And we start the sentence off as the true average ... Describe the situation for me then. So the true average of whatever's going on. Your null hypothesis will always be mu is equal to something. Your alternative hypothesis will be what are we suspicious of? So the null is always the claim. The alternative is what are our suspicions. So our suspicions will either be that we're looking for a decrease or a less than. We're looking for an increase or a greater than. Or we're looking for a not equals. Now, hopefully from the last test you remember, in order to see if it's a less than or a greater than, we need to look at for words that state that. So some sort of comparison word that says less than, greater than, increase, decrease, smaller, bigger. If you look at this problem, we don't see those words at all. We just say, hey, could these scores come from the distribution, the national distribution, or are they not? We're going to start with our null. The null is the claim. So what's the claim right now for the runs? It's 5.7. There are no words in this problem. If you go back up and read through the problem, there are no words that say increase or decrease. So we're just going to see, do we have evidence that it's different? This is what we call a two-tailed test. Why is it a two-sided test? That's important for the do part. And then finally, we need to describe the mu. When you have a not equals. Whenever you have a not equals. Okay, so the true average situation. What's the situation here?
Scoring runs.
Yeah, scoring runs for this team. All right, sometimes people don't always know how to start these problems. Some people like to start, this is just a suggestion, is to start off with the HA. What are we suspicious of? You don't have to start off that way, but that can help, okay? What are we suspicious of? So I'll give you a second there to write down that little helpful hint. If you're curious, like I don't know where to begin, I don't know where to start, the next one would be what's the claim, okay? What's going on? Now, as you're writing, the next part of a significance test is the plan part. That's where we're proving that we can use a certain test. We can use the yellow chart to get a T-score. We can use the chart to get a Z-score. We don't do that in Intro to Stats. You'll do that when you get to college. So we jump then to the do part. The do part is worth the most points on your test. The expectations for your do part are below here. The first thing I want for the sampling distribution is I want your curve, the mu, and the standard error. Am I going too fast right now? Not. All right. So we have our curve. Your mu goes in the center always. And this always comes from the null hypothesis. Mu is equal to 5.7. Your standard error is a formula. It is Sx divided by the square root of n. So I take my Sx that I found, and the Sx that I found was 2.88, is that correct? Okay, 2.88. And we're going to divide it by the square root of n. N is 5 because there's 5 gains. When we do that, 2.88 divided by the square root of 5, we get 1.29. So our standard error is 1.29. Next, we need to mark our statistic. That's our X bar that we found right away.
What is that O supposed to stand for?
That's sigma. So that's the population standard deviation that we're estimating, and that's why we call it the standard error instead. Okay, another Greek letter for you. X bar we already found. What was it? 7.4. Now, instead of finding a z-score, because we're using the t distribution that goes with your means, your quantitative data, we're going to find the t-score. And there's your formula for the t-score. So my t-score is equal to 7.4 minus 5.7 divided by 1.2, was it 29? Yes? What was my standard error? 1.29, thank you. Be careful how you type this in your calculator, you guys. Make sure that you do the numerator first, hit enter, and then divide by the denominator, or use parentheses. So I got a t-score of 1.32. Can you guys confirm that? Okay, 1.32. Now, instead of finding a p-value next, we're going to find the critical value. We're not going to find a p-value this time. We're going to find a critical value. And how we do that is we first need to find our degrees of freedom. Our degrees of freedom are still the same that they've always been. N minus 1. So my df, my degrees of freedom, is going to be 5 minus 1, which is equal to 4. And then I need my critical value. And how I get my critical value is not that difficult, but please write down the steps first. We need to use our significance level to find the critical value. And in order to do that, if it's two-sided, so for only if it's not equal, we need to divide the alpha by 2, okay? So I'm on a quest right now to find this critical value. How do I find this critical value? Well, I need to use the significance level. So I'm going to state what my significance level is. And it says in the problem that alpha is equal to 0.05. Because it's a two-sided test, which means the HA, the alternative, is a not equal to, I need to divide 0.05 by 2. I use my alpha to find my critical value. We need to go to the chart now. Flip to your chart when you're ready. some people still writing, so I'll give you a second. You guys are doing a nice job. I know it's hard on a nice day. Okay, so this is a little bit different than when we did the confidence interval. What we're going to do is we're going to go to the chart, and instead of looking at the bottom, we actually look at the top. Not much more. We're going to conclude in a second, okay? So we have our alpha up here. So highlight that, that's your alpha level. We have our degrees of freedom right here. Our alpha level is no longer 0.05, it's 0.025 because it's two-sided. So I go right there. My degrees of freedom are 4. And right here is my critical value. So instead of finding a p-value, we're finding a critical value. Just like before, once we found a p-value, we can compare it to alpha and conclude. Now we're going to take our critical value compared to our t-score and conclude. Let's write down our critical value. .776. I need to compare my critical value to my t-score. One of two options will happen for the conclude. The first option that could happen is my critical value could be less than my t-score. So just like with the p-value, when the p-value was less than my alpha, I rejected the null hypothesis. Here my critical value is less than my t-score, so I reject the null hypothesis. Write it down just so you have it down, because it is different than the p-value from our z-test. Yeah, it is a fill in the blank, and I'll show you here in a second. I don't care in the conclusion if you actually tell me what the critical value is, as long as it's shown above. So you can just say, because the critical value is less than the t-score, we reject the null hypothesis. We have evidence for HA, and HA does need to be in context. You guys did a nice job on your test on those. Again, context means tell me the story behind the situation. What's going on? And if you don't reject the null hypothesis, we fail to reject it. So this is 2.
How is the critical value less than t-score? It looks like it's greater than.
Ours is greater than, but these are the 2 options that I want you to have. So you know, you're going to look at your notes and you say, okay, my critical value is less than t, what do I do? Or my critical value is greater than t, this is what I do. So it's like an either or, like a choose your own adventure. Here we go. What do I have? Which one am I going to choose? Okay? All right, so our critical value is bigger than t-score. Do you guys see that? All of you? So our critical value was 2.776, and our t-score is 1.32. So since our critical value is greater than our t-score, we reject the null hypothesis. I'm going to type it out for you right now so you know how to write it. And I'm going to make sure it's in context, and then we are done for the day. So because our critical value is less than our t-score, we fail to reject the null hypothesis. The null hypothesis does not need to be in context. We have no evidence for HA. And now HA has got to be in context. So what's going on with this situation? The true average runs for this team is different than the national average. We have no evidence for that. So we have no evidence. Let's not say for, let's say that's. Sure, that's fine. That's fine. We have no evidence that the true average runs for this team is different than the national average. Hopefully it's on a leg right now, so hopefully it'll come out. There we go. Oh my gosh, you guys. My computer's freaking out. All right, I am done for the day. I'm going to pass out your homework, but you have all day on Monday to do it. It is a packet. All right, you guys, really quick. One of our faithful students here, notice I wrote it wrong. Our critical value is greater than. Yeah, thank you. We failed to reject the null hypothesis. I did that part right, at least. We have no evidence that the true average runs for this team is different than the national average. All right, and we're done. Uh-oh. What? The first slide? Yep. Give me 1 second. Let me just stop this recording. Oh, no, you guys.